Bienvenidos, Hushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this video tutorial, we're going to be taking a deeper dive look at Packet Tracer Activity 10.2.1, where we're going to be configuring multi-area OSPF. And so in all of our previous OSPF packet tracer activities, we've been working with OSPFv2. Remember, OSPFv2, it is implicit that when you say that, you're talking about OSPF for IPv4. Now, talking about OSPFv3, which is defined in RFC 5340 that we're going to be taking a look at here shortly, we're talking about OSPF for IPv6. Now, OSPFv3 is almost a complete rewrite from OSPFv2. It was an opportunity to address a lot of the deficiencies that they discovered in OSPFv2, as well as to uplift it to support IPv6. And so let's take a look at the RFC right out of the gate. So again, OSPFv3 is OSPF for IPv6, and you can see that John T. Moy was still involved in the write-up for OSPF for IPv6. Now, the important section for learners looking to transition from for OSPFv2 to OSPFv3 is probably section 2 right out of the gate. And it details a lot of the differences from OSPF for IPv4 and between OSPF for IPv4 or OSPFv2 and OSPFv3. You can see protocol processing on a per link, not per subnet, with OSPFv3. Removal of the addressing semantics. And this is important because we're going to see and talk about new link state advertisements, new LSAs. And I know a lot of learners get very frustrated with this because they've just gotten down the link state advertisements, the LSAs for OSPFv2, and now they're told, hey, great news, in OSPFv3, 2 of the LSAs that you've just memorized or just remembered the names for, 2 of those names have changed in OSPFv3, and we've added in 2 additional LSA types. And so, again, the removal of the addressing semantics, you can see that the addresses, the IPv6 addresses, are not present in the OSPF packets like they used to be. Again, except in LSA payloads carried by the link state update packets. And so definitely take a read through section 2 of the RFC because this gives you a lot of additional information. Now, something that we're going to see here in just a second is the OSPF router IDs and area IDs and LSA link state IDs remain at the IPv4 size of 32 bits. In other words, even if we're running OSPFv3, the router ID is still going to be the 32-bit dotted decimal notation that looks just like an IP address. That is what's going to be used for the router ID. Now, it has to be configured specifically because, think it through, if I'm in a pure, meaning non-dual stack environment, and let's define dual stack. The IPv4 protocol stack and the IPv6 protocol stack, those are 2 mutually exclusive networking stacks. The addresses are different, as I'm sure you know, right? 32-bit for IPv4 versus 128-bit for IPv6. And if we're doing dual stack, it means we're running OSPF for IPv4 and OSPF for IPv6. Those 2 stacks are running on the same device. That is referred to as dual stack. And so if we're running a pure OSPFv3, I'm not talking about address families yet, but just a pure OSPFv3 routing domain, we might not have any IPv4 addresses. There might not be IPv4 loopbacks from which to pick, or interfaces that are up with IPv4 addresses on them to get the router ID configuration for OSPF, or to get the router ID value for OSPF. And so with OSPFv3, that's something that we're going to need to be setting manually. All right, so let's take a look now at the activity. So here we are, activity 10.2.1, and it is a short activity. We'll be basically configuring multi-area OSPFv3. You can see we've got router A, router B, and router C. And what routers are the area border routers? So those names don't change, right? And you can see here, router A is an area border router because by definition it has an interface in area 0 and at least one interface in a non-area 0 area. That is an ABR. Router C is an area border router as well. Router B would be considered a backbone internal router because all of its interfaces are in area 0. And this might look very similar to another activity that we just did. And in fact, all they did was sort of move things around a little bit. But for all intents and purposes, this activity is very similar to 9.2.2, where we took a look at multi-area OSPFv2. All right, so let's get these routers up here, and then let's start to get things configured. And so we're going to configure OSPFv3. Now remember, we're using IPv6, and by default, Cisco routers do not have IPv6 enabled, right? And so for routing. And so if I come in here and go from user exec to privilege exec and then into global config, and let's go ahead and try to do this. So I want to force the error message that you would see. So if I was to say, and now remember, we're going to be configuring, this is configuring OSPFv3. So I don't say router OSPF1, right? You can see it says configure OSPFv3 on router A with a process ID of 1 and a router ID of 1111. Well, if I say that, that's OSPFv2. The nice thing about OSPFv3 is you really just kind of insert the keyword IPv6, router OSPF1. So the command is identical with the exception that we add in the IPv6. And I hit enter, and what do we see? And this is the error I was trying to force. You see that IPv6 routing is not enabled. Well, that's an easy fix. We simply say IPv6 unicast routing. Now that enables IPv6 unicast routing and will enable me to now start the configuration for OSPFv3. And then here is a warning syslog message from OSPFv3 saying no router ID. And you see that OSPFv3 could not pick a router ID, configure manually. And that's because this is an all IPv6 configuration. But we know the command router ID 1111, and that's really all that's going to be required. So we enabled IPv6 routing. We configured OSPFv3 with the router ID of 1111 and the process ID of just simply 1. Now, step 2 is we're going to configure each active IPv6 interface with OSPFv3, assigning each to the area listed in the addressing table. And so, again, from looking at the diagram, you really don't need to go back to the addressing table here other than maybe to see the interfaces. So it's going to be gig 0001 and then serial 000. Now, this link local value is on all of the interfaces. Remember, a link local IPv6 address is local to the link on which it is configured, meaning I can configure fast Ethernet. I can configure FE80::A on every single interface on router A, and that is okay because it is local to that link. It is not going to be advertised or routed. It is local to the link. And so we'll come down here. And a quick note, those 169.254 addresses that I was using in my VRF Lite supplemental video tutorials, a lot of learners will think that, oh, link local is an IPv6 only construct, and that is not true. If we pull the browser back up and let's go ahead and say IPv4 link local addresses RFC. And you might not know, and you can see I've had this up multiple times before over the years, RFC 3927, dynamic configuration of IPv4 link local addresses. And that dynamic configuration, right, it's talking about those APIPA addresses that we end up with when DHCP doesn't function the way we hoped it would. And take a look. This document describes how a host may automagically configure an interface with an IPv4 address within the 169.254/16 prefix that is valid for communication with other devices connected to the same physical or logical link. These are IPv4 link local addresses. So a lot of learners will think that, oh, link local, it has to be IPv6. Not the case. And again, transit links are great candidates for link local addressing, whether it be IPv4 or IPv6. And as you're going to see, when we configure OSPFv3, it will be using the link local address for the adjacency, not the global unicast addresses. Again, so another slight difference there. So we've got our router ID configured, so gig 0100 and serial 000. And so we're going to advertise each directly connected network. All right, so in order to advertise the networks, right, and this is, again, some of these things that are different, I could say passive interface, right? We could do passive interface, I could do some redistribution, but let me ask you this. So where is the network command here under IPv6 router OSPF1? There is no network command because we're no longer dealing with subnets and subnet mask lengths that get converted into wildcard masks. We're dealing with prefixes and prefix lengths. And so again, that's different. And to be honest with you, I prefer this, right? Because you're not hassling with with wildcard masks, and you can do this in IPv4. And all we would need to do is go into and do show IP interface brief. Let's see all the interfaces. So, do show IPv6 interface brief, and we'll see the interfaces that are configured here. Again, making that transition from doing a whole bunch of IPv4 stuff to then saying, all right, now it's all IPv6. You might see me put IP instead of IPv6, but we'll get it corrected. So it's super simple to do this. I go into int gigabit Ethernet 00, and I simply say, and this is where you could have put the command IP OSPF1 area, and I'm on router A. So this is going to be area 1. That would be the IPv4 OSPFv2 command under the interface to place that interface into area 1 and to run the OSPF process on it. And the difference is just that. IPv6 OSPF1 area 1. And that's the only command that's needed there, right? There's no network statement where you've got to put in that just unruly global unicast address for the interface, or I'm sorry, put the link local in there with some kind of a prefix length, prefix mask on it, prefix length on it. And so there we go. So now let's go into interface gigabit Ethernet 01. And the nice thing is the gigabit Ethernet interfaces are both in the same OSPF area and the same OSPF process. So now we're going to go into interface serial 000. And you can see both of our adjacencies have come up. And how are the routers identified? It's not based on the IPv6 format for the router ID. It's IPv4. And so we can assume here we're dealing with router 11 and router 12. So I go into the serial interface, and all I have to change is just make it area 0. So IPv6 OSPF1 area 0. Instead of the OSPF2 syntax, which would just simply be IP OSPF1 area 0, we just say IPv6. And there we go. And so we've got that dropped in there. We picked up a few points, made it all the way to 33%. And give me a second here. So let's go ahead and say show IP OSPF database. What are we going to see? Yeah, trick question, right? Well, we don't see anything. And this is typically, again, making that transition between V4 and V6 can sometimes be a little tricky, and you may see things that you don't expect to see. And let's stretch this out here. So here is the show IP OSPF, show IPv6 OSPF database. And again, right now, we only see information for area 1. Now, the other thing you might notice, oh, I'm sorry. That's right. We did put that interface in area 0. So, but back to this area 1 up here. Take a look at this. We see a link type 8. And then we see this intra-area prefix link state, which might be the type 9. And then take a look at the name here. We see this inter-area prefix link state. So we're seeing some different names, right? Maybe some of the same information or similar information, but this one here and this intra-area link prefix, and we're going to talk about those in a second, these are definitely new, right? So let's take a look at our neighbor. So show IPv6 OSPF neighbor. Show IPv6 OSPF interfaces. And you can see we have the same DR, BDR election action that goes on. We have the same cost values. The shortest path tree is calculating using the same Dijkstra shortest path first algorithm. Again, a lot of the differences, and these are not backward compatible, so you can't run OSPFv2 on one router and expect it to work with OSPFv3. Again, by definition, one is IPv4, the other is IPv6. That's not going to work. So, for the most part, a lot of the changes for OSPFv3, the obvious ones, the cosmetic ones, are all around the IP addressing, right? And around some of the LSAs and the decoupling of the IP address information from specific LSAs. That's no longer done, right? And so, for the most part, with respect to the metrics, right, those are all calculated the same way. If we were to do traffic engineering with the IPOSPF cost command on an interface, that would be done the same way. The hello and dead intervals are the same. Again, definitely take a look at that RFC 5340 and read through section 2, the differences. You'll thank me much later when you have to work with OSPFv3. All right. So those are just a few of the commands. And again, as you saw, we're just literally changing IP, the keyword IP, to IPv6, and we're getting the exact result that we're looking for. All right, so now we're going to repeat steps 1 and 2 on router B and router C. So let's come here to router B. We'll go from user exec to privilege exec into global config, where we simply say IPv6 router OSPF 1. IPv6 isn't started yet. IPv6 unicast routing. Now we can just hit the up arrow. No router ID. So let's set our router ID to 2222. And again, we get some points for that. It's not asking for us to do any passive interface work, right? Other than setting the routing ID, there's really not much we're doing here. We're not even manipulating the auto cost reference bandwidth, which, pop quiz, based on this topology, what would we set that value to? Exactly. We would set it to 1,000, right? Because remember, auto cost reference bandwidth is set in megabits per second. And 1,000 megabits per second is 1 gigabit per second, which is the fastest link in this environment. And so again, just to show you that we can do that, auto cost reference bandwidth, 1,000. Now, we want to make it the same, and we're not going to lose any points here. IPv6 router OSPF1. Auto cost, reference bandwidth, 1,000. And we'll do it on router 3 as well. So back to router B, because router B does have some interfaces that need to be configured here. So do show IPv6 interface brief. And we see that we're going to go into int gigabit Ethernet, 00. I'm sorry. Yeah, that's right. Gigabit Ethernet 00. Sorry, I looked at the 00 and I'm like, yeah, I'm missing my / there. And we're simply going to say IPv6 OSPF1 area. Now, router B, all interfaces are in area 0. And so you can see we've got a router 21 up there in that cloud area 0. And then we're going to go into interface serial 000, hit the up arrow twice. We're going to go into interface serial 001 and hit the up arrow twice. And what we should see here shortly is adjacency between router A and router B. And you can see that that just happened right there. And we know that because there is the router ID value for router A. And now we've gone from loading to full there. So let's take a look at some commands. Show IPv6 OSPF neighbors. I've got 2 neighbors. Why is there no DR/BDR election here between router A and router B? The priority is 0, and we've got this dash here. Pop quiz. Why is that? Exactly, because it is a point-to-point network type. How do we see that? Show IPv6 OSPF interfaces, and they don't support the brief. I don't take it. Yeah, I could say the specific interface, serial 000, so we just see that. And here it is right here. So the network types are the same. Broadcast, point-to-point, point-to-multipoint. And there's my cost value of 64 for that interface. And it looks like, and that's what it would be with the default auto cost reference bandwidth. And did we, I thought we set that here, show run. This may be, again, this may be a packet tracer thing going on. Show run section router OSPF. Yeah, and we did set it, but we'll leave that to the side for right now because packet tracer is not making the change that it should be making. And again, actually, let's not leave that to the side. So again, quick question for you. What would the cost of that serial link be, right, if we're using an auto cost reference bandwidth of 1,000? So remember, if we're saying that 10 to the 8, 1, 2, 3, 4, 5, 6, 7, 8 is the default, if I add another 0 in there, right, for the new auto cost reference bandwidth of 100 million, and let's make sure here, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3. Did I get that wrong? 1, 2, 3, 1, 2, 3, 1, 2, 3 of 100. You know what? I did have it right. I'm sorry. So we want 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. And if I was to divide that by 1,544, remember that's kilobits a second. I need to get it into bits per second. We would get the cost of 64. But that's the cost with the default reference bandwidth of 100 megabits a second. To get the gigabit a second divided by 1544, 123, we should see a cost of 647. And we don't see that. And again, maybe we're waiting for something to happen here on router B, but I thought there would have been enough time for it to make that change. So again, that's how we calculate the cost, the interface cost, the metric cost of the interface. But let's jump back here right now. And in fact, you can see that we've got it set for whatever reason. It's just not showing it. So we'll leave it there. Not a component of the activity we need to get right here. But let's see where we're at. And so now I'm going to go into interface. And actually, I already did the interfaces for both of those routers. I think that's everything. So now let's come over here to router C. And let's wrap up the configuration here on router C. So we'll go into global config. Let's say IPv6 unicast routing first, so we don't see that error. We don't need to see that anymore. And then IPv6 router OSPF1. We set the router ID to the 3s. Now, no passive interface required, but we do want to go ahead and say auto cost reference bandwidth. We want to make it the same all throughout our environment. And so now all that's left is to make sure that our interfaces do show IPv6 interface brief, is that each of these interfaces is properly configured and in the correct area. So we'll go into interface gigabit Ethernet 00, and we simply say IPv6 OSPF1 area 2. And we get a few point, wait a second, I missed the space there, sorry. There we go. All right, and we get a few points for that. And then we'll go into int gigabit Ethernet 01, just hit the up arrow, and we should see that the adjacencies are between routers 31 and 32. And then finally, let's go into our do show IPv6 interface brief. I think it's 000. No, it's 001. Good thing we looked here, 001. And we're simply going to say IPv6 OSPF1 area 0, because that interface is simply in a different area. This is an area border router. And we should see this adjacency come up here in just a second. So we've got the 100%, that's great, but let's continue the conversation here a little bit. Let's say show IPv6 protocols, right? A command that's not listed over here, but one that does have some value. You can see that it shows me that the IPv6 routing protocol that we're using is OSPF1. I've got 2 interfaces in area 2, and it lists the interfaces out. I've got a single interface in area 0. We're not doing any redistribution. So this is a quick way to sort of take a look at which interfaces are running in which area. Let's say show IPv6 OSPF. Now, this is going to show me some additional information, and specifically what we might be looking for here on router C, is we see our protocol information, we've got the hold timer information, the reference bandwidth unit. Now, this is interesting, right? You can see that when we put that auto cost reference bandwidth in there, it looks like it didn't take, which is telling me this is probably why we're not seeing the metric change. Again, if I was to say show IPv6 interface, show IPv6 OSPF interface, serial 001, my guess is, yeah, we still see the same. And so again, packet tracer, this isn't part of the activity, so it's just not changing that. But what we are seeing is it is a point-to-point interface. And then back up here, you can see that what areas are we involved in here? Well, we're involved in area 2, and we're also involved in the backbone area because we have interfaces in each of those areas, and it tells you how many interfaces, number of interfaces in that area. What if I wanted to see the routes? Show IPv6 route. And here are all of the routes in the routing table. And here are what we would call the inner area routes for OSPF. But take a look. If we come up just a little bit here and we take a look at the legend, right, sort of the codes that are being used, what do we see? For the OI. So it's no longer OIA, it's just OI. And here it is right here. It says OSPF inter, right? And so the type 3 LSAs. Now, to be clear, let me go ahead and we're going to do this because this is the last point we're going to touch on here. And that is the following. Remember I talked about the LSAs. Well, I'll put it up here so we don't have to erase it. So the type 3 LSA with OSPFv2, which is for IPv4, we called that the summary LSA. Here, it's referred to as the inter-area prefix LSA for ABRs, right? So I'm just going to say the inter-area prefix, and I'll put a PRE here, PRE, the inter-area prefix LSAs for ABRs, right? So the summary LSA which implies OSPFv2 has been renamed. We still have the type 3 LSA, and that's what we're seeing here. And I'll show you how to see that in a second. We'll look at the database a little bit more closely. But this is the new name in OSPFv3. And if you think about it, it makes sense, right? It's just a lot to remember, but it does make sense. That is an inter-area prefix LSA for area border routers because it is a type 3 and the information it's communicating is inter-area information. Now, if we had a type 4 and a type 5, the type 5 is going to keep its name, but the type 4 has changed its name. Remember, it used to be the ASBR summary, right? Now it's referred to as the inter-area, and I'll just put down, it's this, let's see if it's all the same here, inter-area, so I'll say IA, thinking of a naming convention so I don't have to type out. So it's the inter-area LSA for, what do you think? If the type 3 is for ABRs, remember what the type 4 helps us discover. Helps us find our way to the AS, and that is a terrible B, the ASBRs. And so it's called the inter-area router, I'll put an R in here, inter-area router LSA for ASBRs. And so these are the new names when we're using OSPF or talking about OSPFv3. Now remember I said that a lot of the addressing information has been decoupled from the packets. And these are going to be the two new LSA types. The type 8, which we saw, and it actually says when we said show IPv6 OSPF database, it actually lists the type 8. And so let's do this. Let's get control of the screen back. I don't want to erase anything here. So we're going to have to leave those there for now. So show IPv6 OSPF database. There is, we'll come all the way down here to the bottom, type 8 link states. So what do you think the type 8 LSA is all about? Yeah, it's about the link local addressing, right? It's local link flooding. That is the scope of this LSA. It is never flooded beyond the link. So remember how the type 1s and the type 2s were bound by an area? The type 8 is bound by the link. And that's an important concept to remember. So the type 8 that's running between router A and router B is never going to go beyond this link. That interface right there and that interface serial 000 for both of those routers, that is it. And actually, I think where we, oh, this is, I'm looking on router C here, sorry. So between router C and router B, it would be the serial 001, right? And you can see that those are bound by the link, and that's the type 8. The type, and it's called the link LSA. That is literally the name. So let me write that up here. So it is the link LSA. And very descriptive. It's all about that link local address between these two, the link local address between these two on this local link. And then you have the type 9. Now the type 9 is a little bit different. This is the intra-area prefix LSA. Prefix LSA, or LSAs, right? Now remember that if we have, like, say we're generating a whole bunch of intra-area prefixes, right? This is where the, and let me think of how to phrase this. This is where, so remember the router LSA when we had some addressing information in there? So this is kind of the replacement. This is where the decoupling took place, is that information, the intra-area prefix LSAs, has been moved into its own LSA out of either the type 1 or the type 2, if that makes sense. Those router or the You could think of it as the transit networks for if there was, you had the DR, BDR election. So again, so the router, the type 1 LSA information, that addressing information is now in the type 9. And take a look, here are the type 9s down here. And the shows you the advertising routers. And again, this is for area 0 on router C. If I come up here to router B and we say, show IPv6 OSPF database, you can see that we see the intra-area prefix link states, right? And now let's take a closer look. Show IPv6 OSPF database. And you can see here, we've got the router, the prefix. Now, where we're kind of limited is we can say inter-area, right? The inner area. So let's do that. Inner area. And I could do prefix or router. Let's say inner area prefix. And here are the LSAs with the LSA information. Again, we're seeing the prefixes, we're seeing the prefix links, very similar to when we saw the network and the subnet mask length when we were looking at the IPv4 link state database. And so again, encourage you to take a look at some of these commands. And let's take a look at OSPF database, and we can say router. So here's that type 1 LSA, right? And you'll notice that what we don't see in here is we're not seeing the link information, or I should say, the link state information for the different networks, the different links. What we're seeing are just sort of the transit segments, right? But we're not seeing all of that global unicast information because that information has been moved out of the type 1 into the intra-area prefix LSAs, the type 9s. All right. Well, that is going to do it for this packet tracer tutorial. Again, sort of a quick introduction into OSPFv3, which is OSPF for IPv6. Thank you so much for watching, and I hope to see you in the next video.